One of the biggest boundaries to understanding calculus is the strange and sometimes scary notation. All the different symbols and systems of notation can be messy and confusing. If we take the time to look at the history and people behind calculus, though, we open the door to some truly amazing concepts. The two people credited with inventing calculus are Isaac Newton and Gottfried Leibniz. Although Newton came up with his theory first, sometime around 1665, Leibniz published his ideas in 1684, 3 years before Newton. This is Leibniz's notation for the derivative, which relates an infinitesimally small change in one variable to an infinitesimally small change in another variable. Let's say we want to find the slope of y equals x squared at x equals 2. At first, this doesn't make any sense. How do you find the slope, which is the change in y over the change in x, at a point? The answer is with limits. As delta x and delta y approach 0, we find the slope at an exact point. Leibniz uses the lowercase letter d to represent this infinitely small change in each variable. Next is the integral, which helps us find the area underneath the graph. To do this, we split the region into small rectangles, then add each area together. The more rectangles with smaller widths that we have, the more accurate our estimate will be. In fact, as the width approaches 0, dx, we find the exact area underneath the graph. The height of each rectangle, f of x, is multiplied times the width, dx, giving us the area of each minuscule rectangle. This weird squiggly line is actually a really long letter S. Just like the Greek letter sigma in algebra, this long S represents summation as it adds up all the rectangles between points A and B. Newton's notation is much simpler than Leibniz's. To show the derivative, Newton just places a dot over the variable. To show the second or third derivative, he just adds more dots. And to show the integral, he either puts bars over the variable or places a box around it. While cleaner than Leibniz's notation, much information is left out with this system. Later mathematicians offered their own methods for showing these concepts. Prime or Lagrange notation depicts the function f of x with a prime mark to show the derivative. Like Newton's notation, more marks, or sometimes numbers in parentheses, can be used to express higher-order derivatives. Negative numbers represent antiderivatives, or integrals. This notation also borrows Leibniz's integral symbol to show this. Lagrange's notation is by far the most used in modern mathematics. It takes the best of both Leibniz and Newton's notations and shows this information in a clean, compact way. Another common notation is Euler notation. This system, actually invented by Louis Arbogast, uses the capital letter D as an operator to show the derivative. The order of the derivative is then written in superscript above the D, while the variable is written below. Right after the D, the function being differentiated is written. While many more notations have been used over the years, these are the most common and provide a good introduction to the people and the concepts behind calculus. I hope that you've gained a greater understanding for the history that brought about these notations and this integral part of mathematics.